Okay. So good morning. Welcome back. And then I will announce two things. The first thing is that quiz has been released to you. And sorry for the students who didn't appear 5 minutes ago. And you can take a look. And if you have any questions, teaching assistant will come here after the lecture. All right. So please, if you have any argument or opinion, suggestions, you can talk to her. And the second thing is that next Tuesday will be our midterm one. The range of the test will be chapter 1, 2, 3. Okay. So yeah, good luck. Then let's continue our lecture. Right. So yesterday we talked about chapter 4. The chapter 4 is moment shear diagram. All right. Mainly trying to draw the shear profile or moment profile for this along this axis. Okay. And before that, we need to introduce several symbols and types. The firstly will be the types of support. Different supports will give you different number of reaction force. Okay, so for example, with a triangle shape, it looks like a pin support. Okay, pin support, just like my fingers snap on the clamp on the bar. Okay, so the bar cannot move left and right and up and down, but it can be rotate. So there's no reaction force on moment. Okay, so two reaction force. If this is a roller, which means that it is on the track. Okay, on the track. So the track cannot let the train out of the track. So you cannot up and down. No. So it gives the one y direction reaction force, but it can be slide on x direction. So there's no reaction force in x direction, but it still can rotate. Okay, so there's no moment reaction. And the fixed support, just like my hand grab the bar, and you cannot move left and right, up and down, and also cannot rotate. So there will be it provides three reaction force. The first one x, the other y, and the final m moment. Okay, and then next we introduce loads. Loads, you know, the point loads, what you learn in senior high school, I guess. So P1, P2, P3, and P4, they are all point loads. And the other is distributed load. Distributed load, we need to give you some concept knowledge about the distributed load, because when we are doing force balance, okay, we do the force balance, we will make the distributed load into an effective point load. Okay, and the effective point load value will be the area of that distributed load, and the point load acting on the point. Where is the point? The point is located, penetrate to the centroid of that area. Okay, so this is really important concept. So if you see a really ugly distributed load, for example, Q1, from Q1 gradually increase to Q2, this shape we can divide into two, triangle and rectangle. Okay, rectangle just like this, easy, Q1B, Q1B. So the area is Q1B, and the effective load for this rectangle is penetrating locate at the centroid of the green rectangle. So in the half B. All right. So it should be half B. Let me take a look. So let me write down for this. This is half B. Okay. And of course, this is half C. Sorry, this is a little bit small. I will make you. Okay, see, half C. Okay, and here is half B. All right, and let me make this in the better form. The value is okay. All right, so for the green part, the green part is triangle, right? So the value will be Q2 minus Q1 is the length of the height, and the width B. So Q1 minus Q2 times B divided by 2 will be the value of the effective load, and the location it acting on is at the triangle's centroid. The centroid of the triangle will be 3B over 3. Ugly. Sorry, I will make it beautiful, more beautiful. Okay. B over 3. Big. All right. Can you see that? Okay. Right. So if you can accept this, if you can accept it, you can, calculate the distributed load. Okay. So now, next one, easy. Next one will be, and also the reaction force for this fixed support. You need to write down RA, and this is HA, and this is MA. And you notice that I always give the slash on the arrows represented as a reaction force. Okay, so this fixed support will give the three forces to make this bar remain here to let you see it, because all this load, if there's no fix, this bar will fly away. Okay, but if you see that here, because the support is fixing them, so these value determine the value of the reaction force. Okay, then another thing is that if there's a M1 here, and all you need to do is write down there will be RA, and there's HA. Well, there's no HA actually, because there's no horizontal. Okay, so this should be 0, and it always give the roller will give you a y direction reaction. So basically that's it. All right. So when you see a structure, when you see the materials looks like here, and firstly we need to identify the reaction force, and then we need to balance this. Okay. So in next page, I'm going to give you an example trying to determine the reaction force. So before you do everything, before you do anything, okay, you need to balance the force and then determine the reaction force. All right. Next, I'm going to do the calculate reaction force by force balancing. Okay, so there are, so you can see that this is just P1, P2, and Q. Q. Okay, and so this is the problem you see that in the test, okay, in your exam, and then maybe in your quiz and your midterm 2, not in midterm 1, all right? Don't worry about that. So when you see this figure, and then we are going to start from here. Let's solve this problem, start from here. We firstly identify, okay, this is a hinge at A. So there are RA here and HA here, okay? And B is a roller, so you only provide the RB as the Y direction, but there's no X direction because no X reaction force because this is a roller, so it can be, move in along X freely. Okay, so 3 of them are our unknown, okay, unknown. HA, RA, RB, unknown is our reaction force, okay? Then, now we're going to balance the force. Before the balance force, we need to process the force here. P1 here, you have alpha angle. So you will have the Y direction component and X direction component, okay? Of course, the P1 equal, the P1 for horizontal, this part is P1 cosine alpha, okay? P1 cosine alpha. So HA is positive, you assume that positive, and this is negative direction. So HA minus P1 cosine alpha equal to 0. So HA equal to P1 cosine alpha. Very easy, right? So this is the X direction, horizontal direction force balance. And now we're going to determine the RA and RB. But RA and RB related to the Y direction. So we need to process this Q here again. So you can see that QC should be the resultant effective force. Q times C. The Q times C is the area of this. The Q here is the height, right? The C is the length. So Q times C is the effective load for this distribution load. And acting on, you know that this is a half C. Half C. All right. Then you can do moment balance at B. So if you choose origin B here, you can see that for this part, QC is rotate counterclockwise. So this is positive, okay? QC is positive, okay? QC times the force on half C. So you have this turn, and P2 is positive because counterclockwise, but P2 times L minus B, P2 times L minus B, sorry, P2 times L minus B. So this is the second contribution, and the P1 for this vertical direction, P1 is also counterclockwise, is positive. So positive P1 sine alpha times L minus A. So this is the length of the force arm. So third contribution, okay? And the final one, RA, RA is rotate about the B clockwise. So it's minus RAL. So all you need to do is just do the force moment balance, and you can get RA equal to blah, 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 blah. All right. Then your RA has done. How about RB? Well, RB, you have two solutions. The first one is that you make the moment here about A as an origin. So you can see P1 sine alpha is counterclockwise minus P2 counterclockwise P2B, and QC counterclockwise minus L minus half C, and RB is wow, these three are all clockwise, so it's they are minus. Okay, then RB is counterclockwise, it's plus, so it's a plus RBL. Okay, so you can obtain this RB from this moment balance, or you can do sigma Fy equal to 0. Then you can use your RA and P1, P2, QC to solve RB. Okay, so both of them are all okay. Both of them are okay. So you can also use the or you use sigma Fy equal to 0. Okay, you will get exactly the same value. Okay, so I guess you understand what we are doing here, but this is an important step. Every problem, you need to do that first. Then we are going to introduce the shear forces and bending moment. All right. Okay. So let's continue. Next, let's talk about shear force and bending moment in the material. As we can see that before we do the calculation, we need to introduce sign convention. What is positive? What is negative? This is a little bit different from your concept, so be careful about this. All right. So now there's a problem looks like this. All right, and the force has there's a force acting on point A, and you see this B is a fixed load, right? So you have RB and MB, of course, but maybe we have RBH, right? But there's no horizontal force, so RBH will be 0. So I neglect it. All right. So this is the problem. You see that in chapter 4, okay, in your exam, in your homework. Now we are going to draw the shear force diagram or moment diagram. The shear force and moment diagram are the diagram that showing different value of shear along the x. So we will draw when x equal to 0, what is shear force? When x equal to the next step, what is the shear force? So you will see a force like the diagram like this, something like that. Okay, so your shear force will vary with x. Okay, this is the result. So let me oh, there's no example. Okay, so I just want you to know that our diagram is changing with x. So moment value will changing with x. Shear force will changing with x. So you can draw a figure. Okay, and then again, a question will ask you. A really typical question, a very common question. You have heard that many times. If you want to know how many how big, okay, of the shear force at certain point, what should you do? You just cut it, right? You just cut it. Okay, so we cut it. Okay, if I want to know that point distance from the origin x, and then we want to know the shear force and moment, I just cut it and left the left hand side or left the right hand side. Both are okay, right? So I left hand side and left right hand side. Okay, then if I left hand side, we can see the P here, and if we left the right hand side, we cannot see any P, right? So here and here after the cut. Okay, now very important. So you can see that this figure small b here, if you have P here, there must be a force at this cross section. Must be a force or bending. Otherwise, this blue material will fly away, right? So there must be a force downward to balance the force P upward. All right, and then you see that after that, okay, but you see this material will rotate, so must be something else. It rotates clockwise, so it must have something counterclockwise. Okay, counterclockwise to cancel the clockwise rotation due to the P couple. Okay, so this two arrows I added here is the shear and moment at that point and at that section. OK， 听得懂吗？我们刚刚说啊，简历弯曲图就是在画每一个 x 的位置，从左边到右边，每一点的简历值跟弯曲值，所以你可以想象哦，可能它会越来越高，简历会越来越高，然后忽然变低啊，或怎样哦，然后弯曲可能会越来越高啊，怎样 ，OK， 这就是简历弯曲图的长相。但是我们要画之前，我们要先给你们看正负号的，就是要先给你看正负号的法则啦，规定啊，没有为什么 ，OK。然后呢，我们就说有个问题，就是我们要看哪一点的简历值或弯曲值怎么样，就切它嘛，我们就切它下来。那切它下来，你可以留左边或留右边，对不对哈？所谓的正负号就是我要留哪一边当作为基准了哈。等一下我就跟大家讲，都要留左边哈，都要留左边。好，然后我切完以后呢，我刚刚解释的就是说，如果切了以后这边是空空的吗？刚开始空空的，我们看这个 P 往上，它绝对是往下才能 balance 它，对不对哈？一定有一个力在这里，你这边都没有力啊，你看不到啊，对不对哈？没有力，但你一切开来，一定有这边有个力，它会 balance 它，所以它如果往上，它就一定往下。OK， 那这个就是它这个截面的简力，对不对？你可以发现这个力会平行于这个截面嘛，对不对？好，所以当然是简力咯，所以这就是简力弯曲图的简力。简力 V 一定会跟 P 一样。好啦，它解决了 FY 方向的 balance 以后，但你会发现不够啊，它会造成顺时针的旋转。那所以说，我们一定这边还有一个反方向的弯曲去取消掉它的顺时针旋转，这边是逆时针嘛，哈，这样这个东西才会安安稳稳在这边让你看到 ，OK， 才会得到力平衡。All right, so that's the concept. So you can imagine that different cut, you might end up different V and M. Okay, not in this case. This case is too simple. Okay, so if you have other force and other moment on the material, your V and M will change through the X. Okay, then if you understand, so if your knowledge is kind of, if you took my course with your effort, you know that the opposite side of the right-hand side will have upward V, and the other side of M clockwise. So this V and this V will cancel each other, and this M and this M will cancel each other when they attach these two sections back together, and you don't see anything in the material in the whole body because they are internal force. When they attach together, they will disappear. Okay, so these two must be direction reversed, but the same value. Okay, of course, this one will be balanced with the fixed end. Okay, but we are not going to take a look about this because in the psi convention in this course, we will select this one. We will select this one, not select that one. Okay, psi convention in this material course, we say downward V is positive. Upward M is positive. Okay, and we always calculate the right-hand side of the section, not the left-hand side of the section. All right, so be careful, be careful. Okay, so you can see that if we plot them together, okay, if we plot them together, we choose this side. We choose this side, okay? We choose this side, not the right-hand side, okay? And there are a point like this, okay? And we say, sorry, I will make it more far away, okay? So this is up, sorry, this is up. And this is, okay, right. So shear force. So shear force clockwise about the point is positive, and moment upward is positive. Okay. Okay, so that's some sort of you see, for this point, okay, this point, the shear make the clockwise about the point, is positive. Or if you can say this one, yeah, clockwise, right? And moment upward is positive. All right, but well, just want you to know that you need to draw the value based on, if you cut it, you leave left-hand side. Okay, this is the sign convention. Otherwise, you will have ends up all the value with the negative negative to others. Okay, opposite side of others. Actually, I remember different countries using different sign convention. All right, I remember maybe European use different choose this side. OK， 听懂吗？我说我曾经看过网络上有人用不同的系统，他们一样画简历关系图，但整个跟我们相反，就正负符号相反，因为他们使用的是这一个系统，他们决定在 cut 的时候留右边啊，不是留左边。那美国跟我们学美国的东西嘛，美国的东西，美国的是留左边，好，然后这边往下为 V 往下为正，然后 M 为正，然后 M 是往上为正，就这样。那所以这边要非常小心啊，这边要非常小心。Again, if we cut this shear element, okay, if we cut this shear element here, okay, we will draw this as positive. You see, downward and upward is positive. All right, and if the right hand side, the V and M here, this is negative. Okay, V upward and downward is negative. So, of course, your V here will make it become what? Parallelogy 是不是啊？忘记了，昨天才查过，但是今天忘记了怎么念了，看一下。Parallelogram 是吗 ？Parallelogram, yes, okay, parallelogram. So after the shear, you become parallelogram, okay, and in different shape, all right, positive and negative. And if you have moment like this, you will make it smile. It's positive M, smile, right? Smile, positive M, or cry, negative M. Okay? So this is quite important. All right. So remember that every time we draw the value of the shear diagram and moment diagram, we need to take the right hand side of the section. Okay, the right hand side of the section, and downward V is positive, M upward is positive. All right, careful about this. So you see, this will be a little bit, controversial about your knowledge, because previously we say, force upward is positive, but the only difference is here. Okay, 小心哦，因为这个 V 啊，我们刚刚说我们要留。切完以后留左边嘛，左边留完左边以后，我们的力就会出现在右边的截面上。那这个右边的截面上 ，V 往下是正，这边有一点点跟我们平常的force 往上为正有差别哦，所以这边要小心哦，这边要小心，这是最麻烦的地方。那 M 朝上产生微笑曲线，那就是正。OK， 所以这边要非常小心，好吗 ？Right, so if you can accept that, we can start to do what we are going to do. Okay, so find V and M, find the shear force and moment in this this structure, this material. Okay, the problem looks like P and M. Okay, so there are two forces, P point low, P here, and M no moment at the center. Okay, so now this is a problem. So let's start our solution. It asks us to determine a small distance to the left of the midpoint of the beam. So small distance to the left. So this point, it wants us to determine this point. What is the shear and moment? And this one, a second problem, a small distance to the right of the midpoint. So problem 1, problem 2. Okay, so again, I want to ask, if you want to determine the V and N at certain point, all you need to do is cut it. Okay, we cut it. We cut it. We want to determine the point slightly left or slightly right about the midpoint. So this is first problem, and this is for the second problem. Okay, but before we solve all this value, we need to balance and find the reaction force. Remember that? So what is the reaction force provided by the support? Anyone want to let me know what is the reaction force provided in point A? Anyone? Please. Very nice. Very nice. Because this is the hinge, so they support two reaction force, right? Okay, thank you. So please give me your number. 613 0 0024 024. Okay, very nice. Thank you. Very nice. So we have two reaction force. Anyone want to grab another chance for B? Please. RB to which direction? Vertical. Very nice. Any for horizontal? No. Good. Very nice. RBV. No horizontal because it's a track. Okay, please give me your number. 613 037. Good. Very nice. Very nice. So now we are going to determine three unknown, but actually two, because there's no horizontal force. So IH must be 0. Okay. Now we only have two unknown here. What is two unknown? Two unknown. RAV, RBV. Okay. So RAV, RBV are our two unknown. Okay. So next, we are going to solve the unknown. So sigma MA equal to 0. So this is MA. We make the A here as an origin. P make clockwise. So it become minus P times the force arm quarter L. Okay. And M no. Oh, M no is also a moment, right? M no is moment because we are balancing the moment MA. MA here. Okay. MA is M0. M0 is clockwise. So it also has minus. And you notice that this moment itself, we don't need to times force arm, right? Because this is a moment already. So no need to time force arm, right? Because it already moment in the moment form. The final RB is about A counterclockwise RB. So positive. Positive RB RBV L equal to 0. So your RBV is P divided by 4 plus NO divided by L. Okay, so this your first unknown. How about second unknown? Sigma MB. Well, again, sigma RAV can also done by sigma FY, but here I just let it make it sigma MB equal to 0. and minus RAL. Why? Because RA going to RAV, sorry, RAVL. RAVL, why is minus? Because RAV clockwise rotate about the origin B here. So it's minus, and the force on is entire L. And plus P times 3 over 4L. Again, the P is rotate negative, counterclockwise, sorry, counterclockwise. So it's positive. And the force on will be half L, quarter L plus together, 3 over 4L. And then again, N norm, again, is still clockwise. So still N minus NO, okay? So your RAV equal to 3 over 4 P minus MO divided by L. Okay, so 2 unknown has been done, right? And you see that, yeah, it's quite more or less, you know, a symmetry. Okay, so you done MA, you done RBV and RAV. So now we are ready for problem 1. Problem 1, we cut here. We cut here. Okay, this is really important. We cut here and we said we leave the left-hand side, right? In this chapter for sign convention. So, okay, we leave the left-hand side. What is left-hand side looks like? It looks like this. Okay, and it looks like RAV, right? And this is P. This is P. Should be middle. P and sorry, I will make this point light blue. All right, light blue. Light blue here. Okay, of course, these after we cut it, we will assume that V downward. We assume that V downward and M upward. Okay, assume that because they are positive. And now you know that this M and this V is what we are going to determine, right? And I believe you know how to do that. You can do that in your house, okay, during this week. And then you will know what is M, what is V. And you can also do the second part. Okay? So I guess you know. Anyway, but I will continue my lecture on Wednesday. All right. Tuesday will be our midterm 1. Thank you very much. If you have any questions, come here. Thank you. Bye.